Hello guys, and welcome back to Cheetah Differential Equations. So in the last session we went over linear ordinary differential equations, and today we're gonna start the homogeneous linear differential equations. So what is a homogeneous function? So any function in the form of f and x and y equal to n to the power of alpha, f, x and y is called homogeneous of degree of alpha. And what do we mean by that? So let's take a quick look at an example. So if I say x dy over dx is equal to x tangent of y over x plus y, and then I'm gonna change x to nx and y to ny, and remember n being a constant. Then we're gonna see what happens to this equation, right? So nx dny dnx is equal to nx tangent of ny over nx plus ny, right? And n is not 0. So this n cancels with this n. Here with this, I'm gonna end up with nx dy over dx equal to, let's factor n, x tangent of y over x plus y, and then again I can cancel n. So what am I seeing? F nx and ny is equal to f x and y, which means this is homogeneous of degree 0, correct? Because n to the power of 0 is 1, basically f nx and y is equal to f x and y. So now what happens if is homogeneous? So remember at the very beginning we talked about p x and y dy plus q x and y dx equal to 0, and we could solve this by separating them. Now we can say if p and q are homogeneous of same degree, this is very important, then we can do a change of variable. Of y equal vx, or basically dy equal v dx plus x dv, and using this change of variable we can make a separable and solve it. So let's take a look. I'm just gonna go back to the same equation that we looked as an example. X dy equal over dx equal x tangent y over x plus y. Now I'm gonna say y is equal to vx, and therefore dy is equal dvx plus xdv. Excuse me, vdx. Alright, so we can just substitute now. X vdx plus x dv over dx is equal to x tangent of vx over x plus vx, correct? So here I'm gonna cancel out that one, and I'm gonna factor x on the other side. So x, let's open this up, v dx over dx plus x dv over dx equal x tan v plus v, correct? So I can cancel out x over here, but I'm gonna end that v plus x dv over dx is equal to tan v plus v, and therefore I'm gonna have dv over tan v equal dx over x minus plus. So that being said, this is solvable now, right? So if I integrate dv over tan v, this is easily solvable. This is going to be ln of sin v equal to ln cx, and then from here you can say ln of sin y over x equal to ln cx. So like so, we can solve homogeneous functions. Let's take a look at another example. Dy over dx is equal to x cubed plus y cubed over x y squared. So again, this is homogeneous of degree 0. You can check this yourself. You'll see that fnx and y is equal to fx and y, and therefore I'm gonna use the same y equal vx and dy is equal vdx plus x dv. Doing so, you will get to this point. V plus x dv over dx is equal to v plus 2 over v squared. And from here you'll see that it's 2dx over x equal v squared dv. And from here you can that's what we did, we cancelled out v. We can integrate, correct? I'll end up with 2 ln x plus c equal 1 over 3 v cubed. And you can solve this further. Remember this equation, so it would be y cubed over x cubed equal to 6 ln x plus c, and so on and so forth. Okay, let's take a look at another example. We're gonna look at dy over dx is equal to x squared plus 2y squared over xy. And again, if you check, you will see that f and x and y is equal to f x and y, which means this is homogeneous of degree 0. So now, like before, we're gonna do a change of variable. Y equal vx and dy equal vdx plus x dv. So let's take a look at that. Correct? And then over x vx. So let's open this up. I'm gonna get v plus x dv over dx equal to, and here I'm gonna factorize x squared, 1 plus 2 v squared over x squared v. So I can cancel that one out, and then I'm gonna end up at v plus x dv over dx equal to 1 plus 2 v squared over v. Let's bring that over here. Therefore x dv over dx would be 1 plus 2v squared minus v squared over v. So basically I brought that over and then multiply it by v and add it to the top, which is, we're gonna end up at x dv over dx equal 1 plus v squared over v. And from here it becomes fairly simple, right? So I'm gonna have dx over x, if you flip it over basically, equal to v 1 plus v squared dv. And then we can integrate. If we integrate, you'll see that this is actually ln c x squared equal to ln 1 plus v squared. And then we can say, remember v was equal y over x, right? So basically 1 plus y over x squared is equal to c x squared. Or you can even simplify further, x squared plus y squared is equal c x4. And then let's say if they ask what is f of 0, then I can say x equal to 0, therefore y have to be 0. So f of 0 would be 0. Simple as that. Alright, so that's about it for homogeneous. We're gonna continue on various and specific forms next session. See you guys next time.